Hey folks, how's it going? Hey
Mr.
Demetrius.
Sanderson, what's up, dude?
Hey, just hanging out here from my closet in Seattle.
So, I have on here that your official title is the founder of Data Quality Camp, and I is that what we're gonna do? I mean, you're the data contracts guy. That's what I see you as.
Yeah, well, I'll take it. Unfortunately, there is no role called data contracts guy, but if that's what we need to put me down as, it's fine.
Chief Data Contract. And for everyone that does not know you, I mean, you are one of the best follows on LinkedIn. They should get over and follow you right now if they are not. And I love everything that you talk about when it comes to data quality. There's also an incredible community that you've got going on, which is the Data Quality Camp. I'll go and grab some links to all this and throw them in the chat for everyone in case they want to check out more of that. And I think you've got a pretty rocking presentation for us. Before you jump into it, I want to say that what I was mentioning before is that you talk a lot about how you can't have machine learning without solid data foundations. And that I think resonates with me so much, man. And I know I've said it before to you when we've had conversations, but I want to say it in front of everyone right now. You are so right on that. And so many people just keep talking about it, and it's becoming more and more popular and important. And it is a theme. So I'll hand it off to you now, man. Have fun, break a leg, and let's reconvene in like 25 minutes.
All right, let's do it. Okay, well, hope everybody's doing well this morning. Well, it might not be morning for you, but it is morning for me. So what we're going to be talking about today is data contracts. And when you're thinking about service reliability engineering, one of the big things that's a super hot topic these days is this idea of contracts for microservices. And data contracts are their equivalent, but applied to data. So we can go to the next slide, please. So a little bit about me. I run a community called Data Quality Camp. You can get there just by typing in your browser, dataquality.camp/Slack. It's free. There's over 5,000 people who talk about doing data quality at scale. And I've published a lot of work on data contracts and other things related to data quality and data engineering. And most recently, I was leading the data platform team at a late stage startup called Convoy. And next slide. So when I joined Convoy, what I was actually brought in to do was build out a machine learning program and an experimentation program. Convoy is a very, very heavy ML-oriented business. It's a two-sided marketplace and for freight, and machine learning models and AI systems sat on top of that marketplace and optimized routes and things like that. So there was a huge opportunity. Next slide, please. What actually happened was I was doing constant firefighting. So I managed the data platform team. We were half data engineers, half software engineers that was focusing on infrastructure. And I think, like a lot of people, we were managing, really, really unkempt data foundations. There was SQL queries that were thousands of lines long. We were using the modern data stack, and everybody was going hog wild with it. Our customers, so data scientists, analysts, and BI engineers were all yelling at us pretty much constantly because things were breaking all the time, and there was no real insight into what was causing those breakages or why they were happening. And I had to go back and explain to our leadership why our really cool ML and AI initiatives were not actually working the way that we expected them to. Next slide. So some of the issues that I observed was that we were just having constant failures at basically all levels of the data pipeline. That's starting from our data lake and ending all the way at the dashboard, where in a worst case scenario, some executive would see that numbers were wrong and they would come and yell at me. We also had our data models were increasing exponentially over time. you would imagine that having a great data modeling tool would prevent the spread of additional data models, but this is actually not what happened. We had a ton of monitors as well, which unfortunately led to alert fatigue, where a lot of the data consumers would not even look at alerts or bother writing tests, because there's just so many of them and became very, very problematic and not particularly actionable. And then the on-call for my team was a nightmare. Data engineers hated going on call. It was just constant issues, constant being yelled at, and very, very few satisfying conclusions to projects that we resolved. And then finally, our actual relationship and standing in the organization was quite low. People were always waiting on us. We were never moving fast enough. And as the tech debt increased, our velocity decreased. Next slide, please. So there are three root causes that I detected after about a quarter of looking into this issue and investigating what was going wrong. The first was a visibility issue. You have sort of two sides of data ownership. On one side, you have the data producer, and they're managing, the databases. They might be managing something like Salesforce or SAP, or even an Excel spreadsheet that you're piping into S3. And then on the other side, you've got the consumer, which could be a data engineer that's aggregating a bunch of meaningful data together. Or it might be a data scientist who's then building out data marts or training sets for machine learning models on top of that core infrastructure. And the producers and consumers in that model were not actually talking to each other at all. So the data producers had no idea how the data was being used. The data consumers had no idea who was actually generating that data and why it was being generated in the first place. And then the data engineering team that sat in the middle basically became a bottleneck between these two groups. So overall, nobody really understood on either side how they were affecting each other. Next slide, please. The second problem was that change management for our data infrastructure, for the pipeline itself, was very, very poor. And that was change management across a couple of dimensions. So it could be that the business decided to change, meaning that maybe we added a new contract type or a new shipment type, or we decided to deprecate a shipment type. It wasn't always clear how to factor that into the pipeline and communicate that change. Generally, it would just be a filter that was added on top of a SQL query, and nobody besides the team that knew that had sort of the institutional knowledge would actually benefit from that change. And anyone who consumed the data later wouldn't know why it changed. They would just see the data change for some reason. And the same thing would happen from the producer side. So as new columns were rolled out, as certain columns needed to be deprecated, there was no communication about why this was happening, about when it was happening. And so we became a very reactive environment. And what that led to was a lot of distrust, especially on the consumer side, where they would see a SQL query, and instead of relying on that data and trusting it, they would say, you know what, I don't really trust this. I don't know what's happening in this query. I'm going to need to go back up to source, rebuild things from scratch. And that's what caused a lot of that duplication. Next slide. The last problem, and probably the largest, was ownership, and the lack of ownership, specifically because the data producers, who are obviously an incredibly critical part of this pipeline that I just described, didn't actually take explicit ownership of the data for the purposes of machine learning and analytics. It was just kind of a byproduct to them. We were using the modern data stack. We were plugging into their databases, extracting data on some schedule, dumping it into a lake house. But they didn't care. They're like, look, I expect that any change I make, some data engineer is going to do some magic downstream, and they're going to be able to account for that. I don't need to communicate those changes, and I have no clue whether this data is even useful to the person consuming it. And this caused a lot of problems, with the biggest one being that when things did break, and they broke all the time, no one actually stood up to solve the problem. Next slide, please. So at a very high level, one thing that we observed was that there is this maturity curve in the business in terms of how they use data. And that starts from not really needing it at all, just building creating a first version of the product, trying to find product market fit, but then eventually using data more as a support mechanism for marketing and sales teams. But over time, the data starts to become more and more meaningful, and that the requirement for accuracy increases by quite a lot. Next slide, please. So the high level is that when teams were just getting started with data, it was okay to be directionally correct because you're supporting functions where that the requirement of accuracy is not that high. There's sort of diminishing returns on ROI for accuracy. Data teams are usually very small, so it might be one data engineer, maybe one analyst, one BI engineer, and they just don't have the time to implement quality everywhere. Next slide, please. But once you get to scale, which Convoy was when I arrived and these problems started manifesting, then all of that infrastructure that we created to move quickly becomes a very significant cost. So teams are spending on headcount, they're spending on maintenance, they're spending on actually performing all of the operations in their data warehouse. And when you have this massive cost center, now the business expects there to be an equally massive return on investment. And that's the move that requires this move towards AI, towards machine learning, towards much more concrete data initiatives that solve a business problem. And in that world, the directional scrappy data, it doesn't work anymore. Accuracy is actually a requirement. The maintenance cost is very, very large, and data quality becomes a necessity. Next slide. So you can think about, in the same way there's this business maturity curve of how teams leverage data, there's also a maturity curve and how the data itself needs to evolve depending on the use case. So when we're just doing, answering ad hoc queries, or we're doing some generic exploration, then it's okay if the data is directional and it can rely on faster, scrappier methods. But if data is production grade, meaning it serves a customer, it has an explicit use case, and there's some expectation of quality, then that scrappy model does not actually scale, and we need to do something different. Next slide, please. So high-level summary here is that when data is being used as a support system, it's okay to be lean, it's okay to be scrappy. It's very, very important early on. In fact, it's the expectation early on. So nobody should be blamed for being scrappy earlier. That is the requirement of the company. But as we start thinking about data more as a product, then we need to rethink a lot of the assumptions that we made about what our data infrastructure looks like and the types of investments we put into it. Next slide, please. Okay, so a little bit about the modern data stack. The modern data stack, hopefully everyone knows and understands this, but it's data tooling that is built for the cloud. So you've got tools like dbt, Fivetran, Airflow, Metabase, Snowflake, and really, like, it's an awesome set of tooling to get started quickly. It's primarily plug and play, and it's very easy to use. However, as I just described, being plug and play and easy to use is awesome for at the beginning, but not so great as data begins to mature. Next slide, please. So the pros and cons of the modern data stack is that, number one, on the pros side, it's very, very self-service. It's languages that pretty much any BI engineer or analytics engineer or data engineer can understand and do themselves very quickly. It's all SQL, Python. It's not particularly expensive. A lot of the tools use PLG, so you can just get started oftentimes for free without even needing to pay anything. And this works great. But the cons is that it doesn't really promote that ownership that I mentioned before. And if you don't have great ownership, especially from source systems, then you haven't solved the problem of garbage in, garbage out. And if you go and talk to like really any data person and say, what is the most fundamental issue to solve in all of data? I would probably say that maybe 50% or more would agree that garbage in, garbage out is the most critical. And this fundamentally creates a lot of tech debt that is built on top of the garbage. And there's a lot of other sort of cascading issues that happen as a result of garbage in, garbage out. Next slide, please. So this was more or less the setup that Convoy had, where on the left, we had operational use cases that were supported by databases and microservices and backend developers that were essentially like maintaining these. That data was being extracted on a schedule by batch ELT processes that was dumped into our data lake, which was then pushed to our data warehouse after being transformed by our central data engineering team. But as you can kind of see here, if you're pulling this data on a schedule from an organization that doesn't even know you exist and doesn't really care that you exist, it's going to result in garbage. Next slide, please. And so what we ended up having was a set of non-consensual APIs, as I like to call it. We were treating our data as if it was an API. We were taking a dependency on it. We had an expectation for its timeliness, but it wasn't actually an API because the API owner never agreed, hence the non-consensual element. And that was happening from the database side to the table side to the eventual data model and machine learning or application side. And this created a massive amount of problems. And in my opinion, this is one of the, I would say this is the largest issue to solve in data quality. Next slide, please. So when we're talking about data as a product, what do we really mean by that? Well, what we mean is it's data that is following engineering best practices. So that's focusing on the development and the authoring of APIs, implementing CI/CD, monitoring, essentially data reliability engineering applied to, or reliability engineering applied to data. And what that means is that everybody is responsible for an element of quality at each step of the pipeline. There needs to be some type of conversation happening between these various stakeholders as the data evolves. And there needs to be some best practices that can be leveraged without people having to constantly rack their brain around when to apply them. Next slide, please. So this is a quote by Samuel Goldwyn, which is a verbal contract isn't worth the paper it's been written on. And essentially what this means is having conversations about this stuff is well and good, but you need to go beyond the conversation. You need some mechanism of enforcement. Next slide, please. So what are data contracts? Halfway through the presentation, data contracts are API-based agreements between data producers and data consumers that capture schema, semantics, distributions of the data, and enforcement policies. The short answer is that they are the technical vehicle necessary to implement data products. They are a requirement to effectively implementing data products, in my opinion. There's a few things that data contracts do really well. It's a single surface for collaboration. So you don't have different people speaking different languages. It allows the data model to evolve in an iterative way. And it's about applying data governance very iteratively instead of taking this large, like big blast approach. Next slide, please. So the contract itself is composed of a few different things. One question you might be asking is, well, a contract, that sounds very similar to like a microservice contract or just an API. How is it different? Are we not replicating the same concepts? Well, yes, I would say we are replicating the same concepts. However, we have to apply those concepts for data. That's why it's data reliability engineering and not service reliability engineering. And in data, there's different things that we care about that maybe a typical CRUD API may not care about. Not only do we care about the schema, but we also care about the semantics of the data, meaning what does it mean? If I have a column that's called distance in kilometers, I would always expect that to be true. And if it changed tomorrow to be distance in miles, then that is breaking the API. We also care about different types of validation, like distributions. If I have, let's say, a column that looks at the range of patients' height in the United States, I would expect that to be a normal distribution. And if tomorrow it was bimodal, that's a really big problem. Also, SLAs, things like the freshness of the data are very, very important. So the data contract itself should be a technology agnostic surface that lays out all of these expectations and their constraints. And then it is the implementation of the checks at various parts in the data pipeline. Next slide, please. So in terms of where you, repeated slide, you could just go to the next one. Yes, so data contracts are two pieces. They're the preventative side, meaning we're trying to stop bad data from getting into the pipeline before it happens. This solves the garbage in, garbage out problem. And there's the detection side, which is once things actually break, we need very fast feedback to go back to the producer, who will then ideally treat that issue as a regression and fix the contract. So on the prevention side, we're inserting ourselves into the CI/CD workflow. On the detection side, we're more monitoring what comes after CI/CD because we can't catch everything in a preventative way. Next slide. In terms of how this happens, at a very, very high level, in the CI/CD workflow, like I said, you want to have some definition of your schema in some schema serialization framework. At Convoy, we used Protobuf. We would store that in the Kafka schema registry. Anytime a change was being made to the schema, we would do a backwards incompatibility check. And if that check failed, then we would break the build. So that's how you set this up for any sort of schema checks. And that applies not just in databases, but also in the data warehouse. Anywhere there's a schema, this works. It doesn't have to just be associated with a streaming oriented infrastructure. Next slide. In terms of how you implement the rest of it, I recommend having, like I said, some form of schema registry. There's a set of checks that run during CI/CD. Lineage is really, really important in this system because you need to be able to provide context to data producers about what exactly they're going to be breaking with each change. And you need to give them that information so that they can have the conversation with the right person. For the semantic monitors, you can have checks that run in the stream. You can have monitors that run at the application code level where you're checking each individual value and firing exceptions if you detect a violation to the contract. Or you can use tools like Great Expectations or DBT to have tests in the warehouse itself. In batch, you can do this with monitors. So I'm sure Big Eye has some awesome tooling for this. And the goal is to, once you detect these breaking issues, you roll back to previous versions. Next slide, please. Very quickly, the maturity curve is very, very important here. I'm sure some of you are thinking about the long tail of constraints that you could add to the contract. What I recommend is start very, very simple. Start with schema. We all acknowledge that schema is not the extent of the data contract, but it is the easiest place to take ownership, and it's the easiest place for producers to start gaining awareness of how their data impacts other people downstream. Once that awareness exists, you can begin adding on additional constraints and adding more programmatic checks and breaking changes into the contract. Next slide, please. So in the old world, like I mentioned, can you go back to the previous slide? Yep. So in the old world, we have non-consensual APIs all the way down. And in the new world, what we have is explicit contracts that are taken at each level of transformation and handoff. Next slide. So a big question I get is, what are the actual incentives for data producers to do this work? Three very key ones. Number one, engineers are not bad people. They don't want to break you. They just don't know. And so ensuring that there is very, very tactile feedback and we're clearly communicating context in the developer workflow is very, very important. Using the existing tools, all the systems they're already familiar with, GitHub, Kafka, Protobuf, et cetera, very critical. And then if you're connecting those breaking changes to value generating pipelines, so data products, again, it's much easier to say like, oh, wow, I didn't realize that I was going to be breaking a business critical machine learning model. Maybe I shouldn't deploy this change before having a conversation with the data team. So the key message here is that data contracts should not be applied everywhere, only on the places where there are data products, right? Production grade systems that require that high level of accuracy. Next slide. So when and where to start, basically find those critical data use cases. The smaller the distance there is between the data and consumer and data producer, the better, the easier it is to actually implement the contract. If data quality adds incremental value, then you can do some estimation of how beneficial data quality would be to that particular pipeline, and you will be able to derive some, business-oriented financial prediction on how much you could save or earn if the quality goes up. Okay, next slide, please. So when you start implementing data contracts, really the focus is all about data quality and cost savings. But as you begin to iterate, you can layer on more things. Like we have an iterative surface for data modeling. You have better abstractions, better alerting. And then when you're really mature, you actually have a surface for rolling out more iterative data governance, things like privacy, enforcing various policies, and data security as well. Next slide. So the impact of doing this at Convoy is we rolled out hundreds of data contracts. There was a massive and clearly measurable financial impact on the quality of some of our ML systems and pipelines for accounting that were being audited by the United States government. And the biggest change for me and the most important change was that we started seeing more conversations between data consumers and data producers. In fact, my primary KPI for the project was how many more conversations about data can we start having between those two groups. And next slide, please. So key takeaways: data contracts are data APIs. They cover schema and semantics and anything else the data teams actually care about. They are critical to data product development, and they should be invested in where there is that business critical use case, and you can clearly measure the incremental ROI of data quality. And next slide. And that's it. Thank you, everybody, for the presentation. Like Kyle was saying, I think that DREs is the future. I think that data contracts are going to be a really, really important vehicle for the DRE. And if you want to learn more or talk about it more with me, you can go to dataquality.camp/Slack. I am super accessible, as are 5,000 other people working on this problem. Thank you. I'm done.
Ooh, dude, awesome stuff. As always, I love it. And we've got some great questions coming through in the chat. So while we're waiting for other questions to come in, I want to just see for a minute, because I think you said something there. You were talking about non-consensual APIs, and I don't think you can talk about that, man. You might get canceled.
Oh, really? Okay.
That's
maybe so.
That's some.
I'll take that.
That's not cool. So there's a question from Abraham in the chat, and he's asking about, for checks in the data pipeline, how do you detect an alert on that for data in motion?
Yeah, so it all, to go back to something I said earlier, I think the data contract should be technology agnostic. What's not technology agnostic is the monitors that you apply to check whatever the constraint might be. So it depends a lot on what your tech stack is. If you're using Kafka, for example, then you can have a stream processing layer like Flink or KSQL, and you can write Flink or KSQL queries that are essentially running these checks in the stream. So there's also open source tools like Ylogs is one that does data profiling for the stream, and you can do some checks there. You can run checks on distributions there. So there's a lot of different mechanisms. What I would start from, though, is like what are the constraints that need to exist? What is the earliest place that we can detect this particular constraint? And what is like an open source mechanism of actually monitoring for that change, and then implementing it and tying it to the contract?
Excellent. We've got time for one more question, and it is from Gordon. And speaking of which, there was so Abraham asked that last question, and Roy was awesome in the chat and gave a great answer. Roy, reach out to me. I got a book for you, and I want to give you some swag. So thank you for being great in the chat. Now, the last question is, how do you communicate the, oh God, this is where the Pareto set of critical few data sets versus the trivial many, which is, I guess, the 80-20 principle.
Yes, that's exactly what it is. So if folks aren't familiar with the Pareto distribution, it essentially is exactly what Demetrio said, that there's a small percentage of data pipelines that are responsible for 80% or more of the value of the company. There's probably some automated ways that you could kind of start doing this, but I honestly think the easiest way is to, if you're a data engineering team or data infrastructure team, just see who's complaining the loudest and then go talk to them about what their use case is. This is what happened to me at Convoy. The first group of people that were in the door basically every day when anything went wrong to their data models was our pricing team. And our pricing team was using that data to build a pricing model. And that pricing model saw 100% of revenue at Convoy flow through it. So we're talking on the order of, more than $500 million a year. And if that model had low data quality, then you could see a significant, 10, 20, $50 million business impact. And so they were extremely incentivized to communicate loudly about their data quality issues. I think a lot of these things already exist. You just need to figure out who's complaining the loudest, ask them what their use cases are, and then follow up and try to quantify it as much as you can. I find that every consumer that I have talked to that has a major data quality use case, when I've pressed them on it, they have been able to quantify it or at least express the risk in more qualitative terms. So I would start there. You can do that with 5, 10, 20 potential consumers. I don't know how exactly how many people are at your organization, but then I just like stack rank them, and I describe like which are the 3 or 4 that make up the best story to the executive team. And saying that, we're having to throw out 20 to 30% of the data on the most critical machine learning
Mm.
model at the entire company because a producer is like dropping columns or there's some other sort of like crazy data quality issue, gets everybody's ears to perk up.
Dude, the pain is real. I hear it in your voice. You've got so
Wow,
many scars.
I'm
You
traumatized.
you are traumatized. I see that. All right. I'm not gonna make you have relive these very stressful situations. I'm gonna kick you off now, and I will see you in the data quality camp, man. Thank you for the awesome presentation.
Awesome. Thanks for having me. Bye bye.